All right, guys, this is part 2 of the Keeping It Fresh Chapter 6 video. So number 9 says 19 plus 7 and 4/10. Remember, the key to adding and subtracting decimals is that you need to line up the decimals. Well, I don't see a decimal in 19, so remember, when I don't see a decimal in a number, that means it's all the way at the end, all the way to the right. So 19 is like 19 point, and then I can add as many zeros as I might need to the end of that. So then I'm going to line up the 7 and 4/10 underneath of that. So 0 plus 4 is 4. You bring the decimal down to the same spot in your answer. 9 plus 7 is 16, and carry the 1, and you get 26 and 4/10 for that one. Number 10, you have 120 minus 42 and 8/10. Again, the key is to line up the decimals. So 120 would be 120 point. Looks like I'm going to need 1 0 since I have one number past the decimal and the other number. And then minus 42 and 8/10. I can't take away it from 0, and I can't borrow from this 0. So I'm going to have to go all the way over here to the 2 to borrow. I'm going to make that 10, but then immediately borrow and make it 9. So now 10 minus 8 is 2. Bring down the decimal. 9 minus 2 is 7. Can't take away 4 from 1, so again, I'll need to borrow. And then 11 minus 4 is 7. So we get 77 and 2/10 for that one. Moving on to chapter 3, the directions for 11 and 12 are evaluate when x equals 5 and y equals 20. Evaluate means find the value of, okay? We don't say solve because that's not an equation, it's an expression. So I'm going to take that value for x and that value for y and put them into the right spot in these expressions and then evaluate, simplify, find the value of those. So for 11, it's y divided by 4, sorry for the green squiggly line, minus 3. So we're going to put in 20 for y, so I'm going to have 20 over 4 minus 3. Remember, we put in numbers for variables. We should put them in using parentheses. According to order of operations, this would be division. This is subtraction, so I want to divide first. So 20 divided by 4 is 5, and then 5 minus 3 gives me 2. For number 12, I want to put in 5 where the x is, so I'm going to have 5 plus 16, and that's all over 3, so that means that's being divided by 3. Now remember, this is a special type of problem. That division bar you can think of like a grouping symbol. So that means I need to simplify the numerator, and if necessary, simplify the denominator, and then I can divide at the end. So 5 plus 16, I'm going to do that first. That's 21. Now I'm down to just a single number on top and bottom, so now I can divide. So 21 divided by 3 gives us an answer of 7. Number 13 and 14, we need to simplify the expression. So we have parentheses with a number right next to it. That means we need to use the distributive property. So that means I do 2 times that first quantity and 2 times that second quantity. So 2 times 4x is 8x. 2 times 3 is 6. We rewrite that plus sign in between. I'm just going to bring down this stuff because that was enough work for this step. Now after I've distributed, I want to combine like terms. So that means I need to look for the ones that are the same. Well, here that means there's 2 terms that both have an x in it. So that 8x, and remember it's important to pay attention to the sign in front of the like term there. That's a minus sign. So I'm going to do 8x minus 3x plus 6. So 8 minus 3 is 5. So that means my answer would be 5x plus 6. Same thing with 30. I want to distribute. So I'm going to do 4 times x and 4 times 7. I'm just going to rewrite the 30 in the plus, not doing anything with that this time around. 4 times x would give me 4x. 4 times 7 would give me 28, and I just want to rewrite that subtraction sign from in between. And again, I want to look, excuse me, for like terms. So here my like terms are constants. So I have 30, and pay attention to the sign, minus 28. So I'm going to be doing 30 minus 28 plus 4x. So 30 minus 28 is 2. So my answer would be 2 plus 4x. Both of these problems, the terms that were left in our answers, it was adding in between. So is it okay if you had 6 plus 5x? Yeah, it is, because of the commutative property of addition. Over here, is it okay if you had 4x plus 2? Yes. All right, looking at our next problems. A bunch of stuff from chapter 4. Remember, chapter 4 is all about area of polygons. So number 15 says find the area of the shape to the right. First job would be figuring out, well, what kind of shape is that green shape there. That would be a trapezoid. So then you need to figure out, well, what's the area formula for a trapezoid? So if you remember, the area of a trapezoid is your base 1 plus your base 2 multiplied by your height, and then all of that gets divided by 2. Your bases, remember, are the ones that are parallel to each other, which means they'll never intersect, and they're the ones that make a 90-degree angle with the height. So they show the 90-degree angle symbol here, but there'd also be a 90-degree angle there. So that means 3 and 6 are my base 1 and my base 2. My height always has to make a 90-degree angle with the base, so my height is that 2 over there. So plugging those into the right spots there, that means I'd have 3 plus 6 divided by 2 times the height of 2. Order of ops, add those two numbers in the parentheses together first, so that's going to be 9 times 2 divided by 2. Simplify the numerator, 9 times 2 is 18, and 18 divided by 2 is 9. Don't forget units. The units on our dimensions here were miles, so since we're talking about area, that's units squared, so 9 miles squared. And 16 says find the area of the shape to the right. Well, that shape is a triangle. So the area formula for a triangle would be base times height divided by 2. Remember, with all the shapes we learned in chapter 4, base and height always have to form a 90-degree angle. So 26 here would be my base, and 9 would be my height. So I'm going to do 26 times 9 divided by 2. Remember, we talked about in our class that you can use a little trick. You can take one of these two numbers and divide it by 2, and then multiply by the remaining number. So I'm going to take 26 and divide it by 2 to get 13. Just makes my multiplication a little bit easier. At least that's on your multiplication chart now if you want to look for it. So 13 times 9, we'll do the manual multiplication here. 3 times 9 is 27. 1 times 9 is 9 plus 2 is 11. So 117, and units would be centimeters squared. 17, find the area of the pool. Well, the pool is what we called a composite shape back in chapter 4. That means it's composed of 2 or more shapes that we do actually know how to find the area of, because we don't have a name for this shape. Technically, it's a pentagon, but you guys don't know the area formula for a pentagon. So we're going to split that up. Now, logically, where does that make sense to split it up? Well, they even have this little mark here. Sometimes the markings can give you some clues. Probably makes sense to split that up as a rectangle and a triangle. So I can see the dimensions of my rectangle are 7 for height and 18 for a base. And then over here on the triangle, it says this distance from just here to here would be 3. Well, what that helps me figure out is the height of my triangle, because these are parallel, so those would be the same. So my height is 3 of my triangle. What's my base? Well, this line and this line are parallel, so that means this is a 7 over here. So that's the base of my triangle. So for the rectangle, area of a rectangle is base times height. The base and the height are 18 and 17. So if I write that vertically here so that we can figure it out, 8 times 7 is 56. 1 times 7 is 7, plus 5 is 12. So that's the area of my rectangle. Triangle, I need to do base times height divided by 2. So that's going to be 7 times 3 divided by 2. Well, that would be 21 divided by 2. Well, let's think about that. 21 is like 20 plus 1. So 20 divided by 2 is 10, and then a half, so 10 and a half. So remember, with composite shapes, I need to add these two areas together, the 126 and the 10 and a half. So 126 plus 10 and a half would give me 136 and a half, and then my units would be feet squared. All right, moving on to chapter 7. Write the word sentence as an equation, then solve the equation. Don't worry about this little part up here. That was just when I copied the sheet and I got a little bit extra. So number 18 says 22 is twice a number h. Remember we talked about that is telling you where the equal sign is because we're writing equations, right? So equals. So I know I'm going to have 22 equals twice a number h. Well, they're telling me that I need to use the variable h, and twice means times 2. So I need to do 2 times h. The simplest way to write that is 2h. We then want to solve, so over here let's write it out so we can solve. So 22 equals 2h. Remember, we want to use opposite operations. So since this is multiplying, the opposite would be to divide. Remember to show your work on both sides. We need to do the same thing on both sides. 22 divided by 2 is 11. These 2's cancel out, so I get an answer of 11 equals H. Number 19, 15 equals the sum of a number m and 3. So equals, there's my keyword that tells me where the equal sign is. So 15 equals, sum means addition, so of a number m and 3. So m plus 3 would be your equation. Let's solve it over here. Again, we want to use inverse operations. So the opposite of adding 3 would be to subtract 3 from both sides. So that's going to give us that 12 equals m. 20, the quotient of a number x and 13 is 78. There's my equal sign. Quotient means division. You can show division a few ways. We've been practicing showing it this way in Mrs. Gillespie's class, so x divided by 13. You could also do it this way, and that would be okay. And that should equal means equals 78. So that's your equation, x divided by 13 equals 78. We solve that over here. We want to use opposite operations. So since that means division, the opposite operation would be to multiply. That's going to be a nice big number. Let's figure that out. So 8 times 3 is 24, carry the 2. 7 times 3 is 21, plus 2 is 23. Second row, start with a 0. 8 times 1 is 8. 7 times 1 is 7. Add together, so 4, that's 11, carry the 1, that'd be 10. So we get 1,014 equals x. All right, and our last one, 8 less than a number y is 17. So there's the is. Less than, remember that's the tricky one, so it does mean subtraction, but it means it's in the reverse order of the way they write it in the sentence. So the y actually goes first, then we subtract the 8 equals 17. So over here, let's solve that. Y minus 8 equals 17. I want to add 8 to both sides. That's the opposite operation of subtracting 8. So that's going to give me that y equals 25. 22, a word problem. So it says after 3 rounds, 15 students are eliminated from the geography bee. 55 students are remaining. How many students started in the geography bee? So remember, with word problems, the key is to start with what am I being asked to solve for? We're being asked to solve for how many students started. Pick a variable for that. I'm going to go with, I don't like s because s isn't a good variable to use in math. Looks like a 5. So let's use x. So it says after 3 rounds, 15 students are eliminated from the geography bee. 55 students are remaining. Remember, another hint I give my students is look for a total in the problem. That number is going to be by itself on one side of your equal sign. 55 students are remaining, to me, sounds like a total. So I know it's going to be something equals 55. So what happened with the x and the 15? Well, x is how many students started. 15 students were eliminated. Well, eliminated sounds like what operation to you? Sounds like subtraction to me. So that means I started with x and I eliminated 15. So x minus 15 equals 55. Then we want to solve that. So we're going to use our opposite operations. So the opposite of subtracting 15 would be to add 15. That's going to give you that x equals 70 students. All right. Tell whether the value of the variable is a solution of the inequality. So you're going to take the value of x, the value of y, the value of w, put it in the inequality for the variable, and then determine, is that a true inequality? If so, then your answer is yes. If it's not a true inequality, then your answer is no. So here, x equals 10, we're putting that into the inequality. 3x is greater than 30. So remember, use parentheses when you substitute in. So I'm going to add the 3, and then where the x is, I'm going to put in 10 in parentheses, greater than 30. I need to simplify over here, so 3 times 10 is 30. So remember, this is a question. We're asking ourselves, is that true? Is 30 greater than 30? No, it's not. So that means 10 is not a solution to that inequality. 24, we've got y divided by 2 is less than or equal to 18, and we're testing it for the value y equals 9. So in for y, I'm going to put in my value of 9. I'm still going to have over 2 is less than or equal to 18. We need to simplify over here. 9 divided by 2, what's that? If you're not sure, do some long division off to the side. How many times does 2 go into 9? 4 times. 4 times 2 is 8. Subtract, and I get 1. Can't do a remainder, so you can put a decimal here and add a 0 and bring that down. How many times does 2 go into 10? 5 times. So 9 divided by 2 is 4 and 5 tenths. Is 4 and 5 tenths less than or equal to 18? Yes, it is. So our answer is yes. And 25, we've got w minus 6 is less than or equal to 25 and 2 tenths. And the value we're testing it for is w equals 31. So I'm going to have 31 minus 6 is less than or equal to 25 and 2 tenths. I need to simplify over here, so 31 minus 6 is 25. Is that less than or equal to 25 and 2 tenths? Yep, it sure is. So our answer is yes. Write the word sentence as an inequality, solve, then graph the inequality. So 26, lots of work here to do. We have to write it, we have to solve it, and we have to graph it. So really 3 things that your teachers are going to be looking for here on this problem. Twice a number g is no more than 26. Remember, start left, work right. Almost always, that's the way these go. The only time that doesn't work is with the less than for subtraction. So twice means times 2, a number g, so 2 times g, is no more than. Remember we talked about no more, meaning no, it's not more, it's actually less than, right? It's no more than 26. It can't be any bigger than 26. So that's actually a less than or equal to sign, although it seems a little tricky because you see the word more in it. And then the number, 26. So that's our inequality. That's the first thing we need to do. We then need to solve it and then graph it. So 2g is less than or equal to 26. To solve that, maybe let's write it over here so we got a little room to work with. I want to use opposite operations, so the opposite of multiplying by 2 would be to divide by 2. That's going to give me that g is less than or equal to 13. So remember step 1, number your number line. Decide what kind of dot you need. That's dependent on the sign you have here. So less than or equal to, when it has the line underneath, I know that's a closed dot to indicate that 13 is a part of the solution. Final step is I need to decide which way to shade. I'm shading where those values of g would make this inequality true. So if I read that in words, that's g is less than or equal to 13. So where are the numbers less than or equal to 13 in relation to the dot? 12, 11, those are less than or equal to 13. So that's where I should be shading. Remember, we also talked about the trick where if the variable's on the left, then that inequality sign looks like an arrow pointing in the direction you should shade. But remember, that only works when the variable's on the left. All right, 27, the quotient of a number h in 4 is no less than 2. So left to right quotient means I'm going to be dividing. So I'm going to set up a little fraction bar here. A number h, whatever comes first goes on top, and 4, that's going to go on the bottom, is no less than, no less, not less, so greater than or equal to 2. So our inequality is h divided by 4 is greater than or equal to 2. Let's solve that. Using opposite operations, since that's division, I want to multiply both sides by 4. That'll cancel out, and I'll get h is greater than or equal to 8. So fill in your number line. What kind of dot do we want? We want another closed dot. H is greater than or equal to 8. Where are the numbers greater than or equal to 8? To the right. And again, you can use that trick because the variable's on the left. This looks like an arrow pointing to the right. Chapter 6. Put the numbers in order from least to greatest. Pay attention to those directions. Least to greatest, smallest to biggest. So let's look at 28. We've got -9, 3, 0, -7, 7, and 5. If you think about a number line, you guys are real familiar with positive numbers by now. So you know from 0, we're getting bigger. 1, 2, 3, 4, 5. As we move to the left, we're getting smaller. But that means when you're looking at negative numbers, -1 is bigger than -4 because it's closer to 0. It's getting closer to the positive numbers. So it's kind of like the reverse of the way you think about positive numbers, okay? So here, when you're looking for least to greatest, first of all, you want to look for all the negative numbers. And then out of those negative numbers, you want to look for what would be the biggest if it wasn't negative. Well, 9 would be the biggest, so that's the farthest from 0. So -9 is my smallest. I like to cross them out as I go so I can keep track, make sure I got them all, didn't miss any. Any more negative numbers? Yeah, -7. That's the only negative number left, so I know that must be the next biggest. Then the next biggest I see, no more negatives, but I see a 0, so I know that would be the next biggest. And then from there, we're dealing positive numbers. You guys should be pretty good with the positive numbers. So 3, and then 5, and then 7 would be our order for 28. 29. We have 6, -4, -8, 2, and 1. So start by looking at the negative numbers and find what would be the biggest if we're looking at absolute value. So -8 would be the biggest, so that is actually our smallest. And then -6, -4, that's all my negatives. Now I'm into positives, okay? So then 1, 2, and 6. Last one here, fractions. You're really gonna have to think about this. You might, if you're not too good with knowing like a decimal equivalent to your fractions, you might need to change these all to equivalent denominators. You might need a common denominator for all of these. So I see denominators of 3, 2, and 4. So if you want to change those all to a common denominator, you need to change them all to 12ths. But let's take a look first at what we have and see if we really need to do that or not. We might be able to just figure this out without. So let's start with our negative numbers. We got -1 3/4, -1/2, and -2/3. Well, these ones don't even have a 1 in front of it. This one does. So I know that's got to be my biggest negative. So that's, or smallest negative. So that's my smallest, -1 3/4. Now I know it's between these two. Well, if you're not sure, then you could just get a common denominator for those two. You could change them both to 6. So if I change 2/3 to 6, 3 times 2 gave me 6, so 2 times 2 would be 4. Here, 3 times 2 would give me 6, so 3 times 1. So I've got -4 6 and -3 6. Well, this would be smaller. So -4 6, or the -2/3, would go first, and then my -1/2. Boop, boop. Now we're just down to positive ones. I've got a 1/2 and 3/4. So if you're not sure, you could change those to a common denominator. 2 and 4 would have a common denominator of 4. So I can leave this as just 3/4. 1/2 is 4. 2 times 2 gives me 4. So 1 times 2 means that 1/2 is the same as 2/4. So that means 1/2 would come next. And then 3/4. All right, and then 31 through 33, you're finding the absolute value. Remember, absolute value is its distance from 0. In other words, unless there's a negative sign like this outside the absolute value sign, your answer should be positive. We don't have negative distances. So 31, the absolute value of -16 is 16. -16 is 16 units away from 0. 32, the absolute value of 24 is 24 because it's 24 units away from 0. Now this is kind of the tricky one. Let's do this part first. The absolute value of -7 would be a +7, but then I still have this negative sign outside of it. So my final answer is actually -7. And that's it for our KIF Chapter 6.